Alright, welcome to another episode of our lessons. Today on physics, we want to look at kinematics. What's kinematics? It is the study of motion without the cause of motion. Alright, so in today's lesson, we want to look at distance, displacement, speed and velocity, acceleration, and the equations of motion. Let's start with the first one, which is distance. What is distance? Let's say a particle was at a point called x1 and moved to another point x2. Now the distance is just the space between x1 and x2, which is x2 minus x1. But let's say the body did not stop at x1, the body decided to go from x2 to x3 and then maybe from x3 to x4. Now the distance here is going to be x2 minus x1 plus, we add it to, plus x3 minus x2 plus x4 minus x3. That's to say, we know the space between x1 and x2, we add it to the space between x2 and x3, we add it to the space between x3 and x4. That's the distance that the body has covered. Let's look at the second one quickly. Displacement. What's displacement? It is, I'll say, is the shortest distance between the start point of a body and the end point of a body. So if let's say our body is here at x1 moved to x2, then the displacement of the body is still x2 minus x1, just like the case of the distance. But let's say the body decided to move from x2 to x3 down here. So here, remember the distance between these 2 points is x3 minus x2. So, but that is not, we are not going, for displacement, we are not going to add this to this because that's the distance. We find the shortest distance between the start point where it started and where it ended. So we draw a straight line to join where it started and where it ended. So this point, remember this forms a right angle triangle. So our displacement d is now equal to the square root of, we can start with x2 minus x1 all square plus x3 minus x2 all square. That's the displacement of the body in this case. What if the body decided from this x3 to go to x4 and then maybe at the end of the day it went back to x1? What will be the displacement of the body? We see that the body started from x1 and is now at x1, it ended at x1. That means the body has not been displaced. The displacement in this case is going to be 0. When a body has left its position and returns to its position, the displacement of the body at that instance is 0. That's just the difference between displacement and distance. Alright. Let's look at speed and velocity. What is speed? Speed is the change in distance over time. Remember, let's say we remember our body moved from x1 to x2. It changed its position, and in the course of changing its position, time was used, so it moved from time t1 to time t2. So our speed v is going to be x2 minus x1 all over t2 minus t1. That's the same thing we can use for velocity. We can also say our velocity is equal to x2 minus x1 all over t2 minus t1. In this case, we are using change in displacement as the meaning because velocity is change in displacement all over change in time. But this type of velocity is called the average velocity. That's the average velocity of the body, the change in displacement all over change in time. Alright, so we can say this is change in x all over change in t. What if we are asked to find the instantaneous velocity? That's the velocity at any instant of time. The instantaneous velocity v is going to be the x all over dt. So if I have an x function, I differentiate it with respect to time, I have the instantaneous velocity at that particular time. Let's look at acceleration. So acceleration is the same thing So acceleration in this case is change in velocity. So let's say our velocity started from v2 or v1 rather, v1 and ended at v2 all over t2 minus t1. Or in most cases we use v for the final and u for the initial all over t2 minus t1. This acceleration is called the average acceleration. That's the average acceleration of the body, but for secondary school, that's the acceleration you are likely to use all the time. The change in velocity all over change in time. Remember, change in velocity all over change in time. Now, if our velocity is constant, when our velocity is constant, so when change in velocity here is equals to a constant, that's to say for a period of time the velocity remains the same. What is going to be the acceleration? Let's say v1 or v is equals to u. That's what we are saying. So if v is equals to u, our acceleration here is going to be v minus u, which is still v, all over t2 minus t1. So that will give us 0 all over t2 minus t1. And 0 divided by anything is 0. So at constant velocity, our acceleration is always 0. Remember, acceleration is measured in meters per second squared, velocity is measured in meters per second, speed is measured in meters per second, displacement and distance are measured in meters. So remember, note this, at constant velocity the acceleration is 0. So even if you are given in the question, read through the question. If the question says that the body is moving at constant velocity and then you are asked to find the acceleration of the body, know that the acceleration of the body is already 0, even if other parameters are being given in the question. The velocity or the acceleration of the body at constant velocity is 0. Now let's look at the equations of motion. Let's look at the equations of motion. So the equations of motion, we have the first one as v is equals to u plus at. We have, or we can say we have u is equals to v minus at. That can be our first equation of motion. Number 2, we have s is equals to ut plus half at square. Or if we want to use v instead of that's the final velocity instead of the initial velocity, we are going to have that s is equals to vt minus half at square. Yes, when I'm using v, I'm using minus. When I'm using u, I'm using a plus sign. So the last one, number 3, for this case, we have that v square is equals to u square plus 2as. That's the 3 equations of motion for the horizontal motion body that is moving in the horizontal. What if the body that is going up and coming down? That's motion under gravity. For motion under gravity, we have the first one as v is equals to u plus or minus gt, and the second one we have v or s, h rather, here we use the height, h is equals to ut plus or minus half gt square, and the third one we have that v square is equals to u square plus or minus 2as. Okay, now in this case, whenever you hear that a body starts from rest, we are told that a body starts from rest or a car starts from rest, our initial velocity is always 0 meters per second when it starts from rest. But if you hear that a brake has been applied to the body or it's getting to rest, the body goes to rest, at that case v would become 0 meters per second. But if brake is applied but the body does not come to rest, brake has been applied but the body does not come to rest, our u will be greater than our v. That's to say that the initial velocity of the body should be greater than the final velocity of the body, because the body is decelerating at this case. And if the body is accelerating, that's increasing in speed, that means A is going to be positive. But if the body is decreasing in speed, our A is going to be negative. I'm explaining the equations of motion here, the parameters you are going to be using. Now for this case, for plus, anywhere you see plus, here we use double signs. So for plus, that means that when you have plus G, it means that the body is moving upwards. Sorry, downwards. Is obeying gravity. That's downward. But if we use minus G, that's from here, minus G anything, that means the body is going upwards. Alright, so what if the body is going upwards? If the body is thrown vertically upwards, our V, because it will take a rest at the initial final, at its maximum height, as it's going upwards, it's reducing in speed. So it will have a momentary rest, so our V at the maximum height becomes 0. But if it is thrown from up coming downwards, our U from its initial position becomes 0. So that's all you can have. And in equation in kinematics, just know when to use 0, know when to use minus, know when to use plus, and don't mix up the difference between displacement and distance. Thank you very much. Like, share, and comment.